Hello world, my name is Victor Engelmann, welcome back to my channel. On my channel I have often talked about TCP IP, right? My first video series about operating system development contained the development of a complete TCP IP stack, and on my video series about networks in general, I discussed really the anatomy of TCP IP packets. It's really the offsets and which byte means what and so on. But I've never made a video about how to actually use TCP IP, right, in your everyday programming stuff. So yeah, that's what I'm doing today. On my website I have a little C++ class for TCP clients, and when I looked into that preparing for this video, I was a bit horrified because it was, I don't want to say it was terrible, but it was somehow a bit old school, you know. The whole event handling worked by having function pointers, and then when some data arrived, then this function pointer would be called, and that's the way Ball and C++ builder did its event handling, and that's where I got that idea, but I want to do it a bit more modern today. Okay, as usual I will start with an empty directory. And in here I will create 4 files, a make file, a main.cpp, a TCP Client header file, and a TCP Client CPP file. Okay. But in here, let's say we will create a binary file TCP client, which depends on main CPP and TCP client.o. TCP client.o depends on TCP client.h and TCP client.cpp. Okay. Okay, with G++ we will compile TCP client CPP into TCP client.o. Oops, this should be a $sign here. Okay, so we create TCP client, compiling main CPP and TCP client.o, and instead of main CPP I will write $shift. Okay, the main CPP. Main and argument count, and argument values. Here we will include TCP client.h. Okay, how do we want to use this TCP client? Well, we will have to instantiate it. Then I want to have a method to connect to something. For testing purposes, I will just hard code this to 127.0.0.1 for now. And I want to be able to pass a port here. Okay. Then we will want to be able to send something, like hello world, right? Then we will want to receive some answer. Yeah, we will print this answer to standard out, and then we will disconnect again. Good. Okay, so this should be the API of the class we write now. Okay, we will have a constructor. A destructor. Yeah, a connect method, as I said. With a host name and a port. A method to send some data. A method to receive data. And a method to disconnect. Okay, this is looking pretty good. Now for standard string. I will include the string library. Then, yeah, when we talk to the operating system and tell it to connect to something, then we will get an integer back, which is a handle for the socket. And we will also need a sock header underscore in, which is a C structure, so we put struct in front of it. Which is an internal data structure used to store the server address that we will use for the communication with the operating system. Okay, and for that we will need ARPA/inet.h. Okay. Good. Now for the implementation of these methods. I haven't put include guards here yet, so let's do that right now. if we put this in a namespace, I think it is cleaner to put it in a namespace. Okay, now here in the TCP Client CPP, we enter this namespace so that we don't have to put that in front of every method. And yeah, here we now put the implementation of these methods. I think the destructor should call disconnect. Just in case, if we are still connected, then yeah, if we destroy a connected TCP client, it should be disconnected. I think that makes sense. Okay. Now let's see if this compiles. I think this should compile. Well, here we should return something. Yeah. Okay. Actually, we don't have to include string because we include TCP client.h, and that already includes string. But it's still a better style to include it anyways, so that this file doesn't become invalid if TCP client.h ever decides to change its structure in some way. Okay. this, and the linker failed. Okay. Okay, so now this compiles, so we see that the class is at least somewhat sane. I have all the methods, I have implementation, not really, but all the functions are there, and the main would be able to call all these functions, but they don't do anything yet. So now we will implement them. Okay, I think in the constructor it makes sense to set the socket handle to 0. Okay, how do we connect to something? First of all, we need to create this socket handle here. So we tell the operating system to create a socket and give us a handle to it so that we can then do stuff with that socket. So socket handle equals socket of type AF_inet. So a TCP IP socket. Stream type, and I don't know what 0 is off the top of my head now. Now we have created this socket, and yeah, now we want this socket to connect to some server. So we need an IP address for that server. So there's this function inetAddr which looks at a string and tests if this is an IP address. And if it's an IP address, it assigns that IP address to this IP address data structure here. Okay. But this function requires a C string. Here we have a standard string. So we need to convert that first using .c_string. Okay. But of course, you might want to connect to something through a host name, right? So maybe this string doesn't contain an IP address. So in that case, the IP will be something negative. So if IP equals -1, this is what happens if host is a host name and not an IP address. Then we need to resolve that host name first. So we do that by using struct host end. Get host by name with our host here that we have as a parameter, but this again requires a C string, so we have to do the same thing we did up here, host.c_string. We could get a nullback here, but I will ignore that for now and just pretend I will always get a valid answer. Otherwise you might want to throw an exception or whatever. Or maybe we could use bool as return type and then say if p_server equals null, return false. Okay. Good. Now, I absolutely hate doing the next thing the way that you will always find it. Maybe I will figure out a better way someday, but I mean, the point is we don't know the size of the entry, right? This is just some data from some DNS server, and we don't know, is that an IPv6, is it an IPv4? We don't know the size, okay? So, yeah, memcopy. I hate memcopy because it requires the memory layout to stay exactly the same forever, and yeah, that's not a good thing in my opinion. Okay, server address in address dot s address. So we now set this server address using the data that we get here. To key server, so the thing we got back from the DNS server, host address. Okay, so we copy the host address into this server address and into its internal data structures. Okay, and how many bytes? That's also an information we get from this p server. So p server host length. Okay, that's how many bytes we have to copy, but to be a bit more precise, we multiply this with the size of a character, which is also 1 byte for now, but yeah, to be safe in the future, if that ever changes. Yeah. Okay. So this is what we do if the IP is, or if the host parameter here, if that's a host name instead of an IP, but hey, this IP might have been filled. So what do we do then? Then we set this S address to IP. My old code called this inet address with host.cstring again, but yeah, that doesn't really make sense. It should just be this. Okay, so now our server address object has its IP address. Then we have to give it a port. We do that with the function h2ns. What h2ns does is it converts the port number to big endian byte order. Yeah, because network packets have their bytes in big endian order, and yeah, x86 machines are little endian machines. They just order the bytes of multi-byte integers differently. And yeah, that's why we have to call that. If we had a big endian machine here, I think we could get away with just assigning that number, but even in that case, you should still call H2NS, because big endian machines should have a glibc that has an H2NS that just does nothing. Okay, so in both cases, you would get the value in big endian notation, and then your code is just more portable. Okay. Now set the server address dot syn family to af underscore init. And yeah, now our server address object is done. It has its IP address. Right, this is what we did up here. Then the port and the the protocol family. Okay, so yeah, the server address object is now done, and now we can use that to finally connect. And we connect the socket that, remember up here we created a socket, and now we tell the operating system, hey, I want you to connect that socket to that address. Okay, so socket handle. Okay, this connects, but it might return a negative value if it fails. Okay, so this means that we should be able to connect now. But before I test this, let me let me implement the disconnect also, so that we don't create a socket that then stays open or whatever. Yeah, the disconnect just calls close socket handle. And let's set socket handle then back to 0. Now we will need some more includes. I will include string again, just for good style. Then I will include file control. Which has the open, close, read and write functions. Oh, and I will also include string.h for memcopy. Okay, let's see if this compiles. Oh, of course. So this is a Boolean now. We check if we were able to connect, and then do the stuff only if we were able to connect. Get host by name is unknown. This may be in netdb.h. Okay, this looks much better. Am I missing unistandard.h? Okay, I found the problem. This is really stupid. One thing was that I had an underscore here and had to remove that. But yeah, the bigger problem is that this method was named connect, and for whatever reason, that just made it that just made G++ ignore the other connect method, or function, I should say. And yeah, now I've just renamed it to xconnect, and yeah, as you can see now it compiles. But yeah, anyhow, let's try this out. Okay. As we might have expected, we are getting this error message here. But that is, of course, what we expect, right? It's trying to connect on port 1, 2, 3, 4, 5, but we are not running any server that has port 1, 2, 3, 4, 5 open. So, of course, we cannot connect to it. So, let's open a port. I will use that with netcat. Listen on port 1, 2, 3, 4, 5. And now let's try again. Yeah, and look at that, it now says connected. Okay, it hadn't sent anything, but yeah, the send method is not implemented yet, so that completely makes sense. But we've connected and then disconnected again, and that's already a huge step. Okay, so now let's implement these missing methods. The send method is quite simple. We just call the function write with our socket as our file handle. We just give it the message, but again as a C string. So if we are taking the message as standard string, we have to call .cstring again. And yeah, how many bytes? We can get that from message.size. Okay. Then we can check if n is less than 0, then we had an error. Okay, and yeah, let's do the same thing again. Run our server, connected, and now it has sent something. So yeah, that's really good. put a line feed here. Okay, now let's implement the receive function, but yeah, the receive function is a bit strange, let's say, because we don't know when some data arrives, right? So, and the receive just takes data that's already there, and if there's nothing there, it will just block, and the thread that calls it will then hang, okay, until something arrives. So, okay, let's just start doing it. So first I will create a buffer for the incoming data. And then we just read from our socket handle as file handle. Then we pass it the address of the of this buffer here, which is just the address of the first element in there. And the maximum size. Okay. And then we set the last character to \0. So we will add a null termination. That's why I put this +1 here, so that we are guaranteed to have space for this \0 here, which is the null termination. Now return the message. And let's run our server again. Run the client again. Okay, we didn't get... Yeah, let's just give it a default value of 1 kilobyte. You know what, let's take 2 kilobytes, because it's the maximum size of a network packet. So that means we don't have to split a network packet into multiple receive calls. Okay, it says hello world, and we send an answer, hello there, and here we have received the answer, and we've printed it to standard out. That's what happened here. I just took a lunch break and I thought about this problem with this connect here. I think it might be a namespacing problem, because we are in namespace algorithm here, right? And because of that, I think that things in this namespace are preferred. And that might mean that we have to get out of the namespace first with these : here. Let's try it like this. because there has to be a way to name this the way you want here, right? So let's try again. You see, that's that works, and now we have a nicer name. Okay. Now, right now we have the huge problem that we connect, we send one message, and we receive one message, right? And that's not what happens in reality, right? In reality, you send messages, you receive messages, and you have no control over when you receive messages. So because of that, we should put this receive into its own thread, okay? Okay, now we have the following problem. Right now, we have this one message we send, and we receive one message after that. And yes, that's not what happens in reality, right? In reality, you send messages, you receive messages completely out of band. You don't know when you receive messages, if at all. And yeah, this you shouldn't have your receives interwoven with your sends, because you just have no control over when you receive something, whether you receive something at all. So I think the best solution for that is to put the receive in a different thread. And I mean, the cleanest way to do that, I think, would be to have a separate class for threads and then derive this class from that thread class. But yeah, I don't want to do that right now. I would just weave that into this class here. Okay. To have threads, what do we need? We need to include pthread.h. And then we can instantiate a thread, pthread t. Okay, and I will just have a separate method here. Called receive loop, which is then supposed to receive via some event. Okay. Okay, and what this loop is now supposed to do is it should, yeah, keep receiving like this, but in a loop. Okay. Now let's reuse the buffer all the time. And yeah, now after we've read something, this result n here will be negative if the connection has been closed. So if n is less than 0, then we should break out of this loop. And otherwise, we should do the same thing we did here. So set the last character to a 0 terminator. And at this point, it's really up to you how you want to notify the rest of your application about the situation that data has arrived. As I told you, the old way I did it was with a function pointer. But yeah, function pointers and object-oriented programming are not really friends. So a different way you could do it would be with a method pointer. But yeah, I don't know, method pointers are crazy. I've never really wrapped my head around them. And yeah, that's also not really a modern way to do it anyways. So a better way would be to have a virtual method, and then every time you would need a socket, you would write a new class derived from this socket TCP client class, and then you would override that method. Yeah, that's more object oriented, but yeah, deriving from potentially huge classes, I don't really like doing that myself. So an even more modern way to do it would be to have a publisher and observer pattern, which means that you would define some interface, and yeah, then you would say, hey, you can give me an observer with this type, so an observer that has this interface, and having this interface means having a certain method. So you could give me an object with such a method, and then I would pass my data into that method all the time. Okay, and that's a pretty modern way to do it, but yeah, in the last years we've gone to using lambdas for that, because lambdas are basically the same idea, but you don't have to specify new classes all the time. You just have this you just have one base class, because in the end you are talking about one function that you want to have, and you just need to have maybe some return type, but not even certainly, and you need to be able to put parameters in a certain order in there, right? And lambdas can give you that, and you don't have to specify new classes for that all the time. So let's use lambdas for that. How do you do that? You include functional. Okay. And then you have an object of type standard function with generic parameters for, yeah, let's say void for now, and standard string, const standard string value reference. Okay. I call it callback. Okay. Now put one object of that type into the connect method. I mean, we could do it in the constructor. Whatever. I'll do it in the connect method. So we get a callback, and then we set this callback equals callback. Okay. And then whenever we receive data, we'll call this callback with the message. Okay, now of course we need to start that loop. How do we do that? I think we should do that before connecting, so that we cannot accidentally get some data and not process it. So with pthread create. We talked about that. I won't go into that deeply. We are giving the receive thread object. It's just a handle, but we are giving that to pthread create. We need to give it some function pointer. I will call it start receive loop. And we will give it a pointer to the current object as a parameter to the function. Okay. That normally returns 0, except in an error case. So we can return false if this is unequal 0. Okay. Now we need this start receive loop function. Functions that we can use for for pthread create, must have the signature void star and get a parameter of type void star. So start receive loop. So we are getting this TCP client, this pointer. We are getting that as a void pointer here. So we have to cast that back into a TCP client pointer, and then we can call receive loop on that. Okay, we don't have a way to specify this maximum size at this point. I mean, we cannot get this as a parameter here, but I don't know. I don't care. We'll just use a 2 kilobyte default. Now when we disconnect, we should also join the threads. Okay, the receive loop doesn't have a return value, but this start receive loop has. Why am I using capitalized null? That's in my old code, but that's not how you do it these days. Okay, now let's rewrite our main program a bit. now have to give it a standard function. We just put messages on standard out. Okay. Okay, now what do we do inside this loop? I want this to be a bit like netcat, so that we can input text and whatever we input is sent to the server, and yeah, whatever we get from the server is also given to us on standard out. So let's say we will have a buffer. We will read a line from standard cin into this message. Let's see, let's just do something relatively trivial, like if this message is equal to quit, then we break. Otherwise we send it to the server, and we don't need to explicitly receive anymore. Whatever we receive is getting into this lambda here and will then be printed to standard out. Okay, let's see if that compiles. Okay. It's complaining that it, yeah, I mean it makes sense because where is it? Start receive loop. I'm referencing start receive loop here, but I'm defining it down here, and I haven't declared it anywhere. So at this point, the compiler doesn't know that it will come later. So that makes sense. Yeah, maybe just forward declare it. Looks like it doesn't like this declaration here. I mean, I've told it that I will have this function in namespace algorithman, and I'm working in that namespace here, but maybe it didn't really get that. So okay. At least it compiled. Error, of course, is clear. We don't have the server running. So let's try again. Hey, we are connected. Hello? Hello? Okay, that's pretty cool. I don't really like that I'm not getting the line feed here. So what can we do about that? Yeah, let's just put a line feed here. Oops. Come on. Okay, I'm connected. Okay, now we have line feeds here. That's pretty good. Yeah. Let's see if we now enter quit. Okay, it seems we need to be a bit more drastic here. So I'll include this slash socket.h. for a shutdown function. And instead of closing the socket, we will shut it down with shut underscore rd. After looking into this a bit more, you should call shutdown and also close, because well, shutdown with shut read terminates the read call, but the close call will tell the operating system to free its resources that it's using for that socket. Okay, so if you don't close the socket, then there will just be some garbage resources on the kernel side, and yeah, in our example here, that's not such a big problem because we end the program anyways, but yeah, it's still unclean, and yeah, we really should clean up behind ourselves. Okay, we are connected. Okay, we are exchanging messages, quit, disconnecting, and everything's fine. On the other side, we see the client is gone. Now let's see if we, what happens if we terminate the connection from the other side. Okay, we are connected. Okay, yeah, now that's to be expected, right? The receive thread should end at this point. So the read should fail, it should break here, and then that should end the loop. And then the thread should end, right? So, and that's what I mean. We should have some event handling to deal with the situation at this point, right? So, but I mean, at this point we are stuck in this get line, and I don't know how to kill that directly. I mean, if I tried to send something now, it should fail Yeah, and then because it failed, it should then I think it gets killed at this point because the send should fail here, return false, and then or does it kill the application altogether? I mean, it's trying to send something on a disconnected socket. That's not good. I think the kernel might just kill the process at this point. Let's see. I will set socket handler to 0 at here if one side ends it, and here check that. Okay, we are connected. Disconnect from the server side. Okay, now what happens is that at least this TCP client send returns false. That return false makes us break here, and then this loop is ended. Yeah, this disconnect. I hope this disconnect doesn't get us killed now. Okay, I think at this point it becomes necessary that we have a way to notify our main function about a connection loss on the TCP client side. So I will implement an event for that, just also with a lambda, just like we did before. So we will call on disconnect when the receive loop ends. Yeah, now the connect here needs another lambda. Now we are connected, and we terminate the connection from the client, from the server side. Connection lost. Okay, so at this point the class TCP client does what it is supposed to do, right? It allows us to connect, disconnect, send, receive in a different thread, and it also tells us when the connection is lost. Now, our little test program here doesn't react to that situation very well, because this is a blocking call and we would have to interrupt that in some way, and I don't really want to bother. But that's not the point of this video, right? This is just a little test program, and the important part is the TCP client. The TCP client does what it's supposed to do. Okay, that's all I wanted to do today. But before I end the video, I normally don't plug any personal stuff, but my wife has started a little business where she sells paintings, and I will put links to her website, Facebook and Instagram in the description, and it would be really nice. I would be really happy if you could give her pages a like, or subscribe to her YouTube channel and whatever. And maybe you like the paintings, just buy some paintings. But that's all I wanted to do today. If you like this video, like it, share it, subscribe, and see you next time.